This conference will now be recorded.
Okay, sir. Thank you. Sorry for interruption.
Thank you. Okay, thank you, sir. Now you are observed mode 1, mode 2 in mode 1 in input and output. D4 and D5 is as it is, and INTU sorry, input buffer A. In output mode of the mode 1, D6 and D7, that are the INTA, OBA, merge of these four bits is indicated as the group A. The lower path is act as the group B control signals, either mode 0 or mode 1. It is very important for the mode selections. Next, in previous examinations, draw and explain BSR mode control board format. MSB bit of the CWR is 0. It acts as the bit set and reset board. The first bit is 1 for the set and 0 for the reset, depending on the corresponding D1 and D2, D3. D1 and D2, D1, D2, D3 are used to select the port C individual bits. If the three bits are indicated as the 0, bit 0 is act as the set or reset, and so on of 1, 1, bit 7 of the port C. In BSR mode, only port C communicated to the IO devices, does not supported for the port A and port B. Only port C individually carried bit by bit, either bit 0 of the port PC0 or PC1 or PC2 and so on of PC7. It is the end of the sequence. This is the indicated set and reset. It is a very important from the previous examination question papers. Next, interfacing of the 8255 in asking in previous examination question as this. Interfacing 8255 with the help of 8086. Port A is connected to the LEDs. Port B is connected to the SW2, SW7. SW2, S7 are the switches. Now this diagram is the shows. Port A is connected to the LEDs. There are 7 LEDs. Port B is connected to the LEDs is indicated as the output. Therefore, port A is act as the output. Port B is connected to the keyboard. It is the services switching connection input of the port B not to B7. Port B is you are pressing any one of the key, read that information, corresponding value services to the first key is the pressing, first LED is the globe, second key is the pressing, second LED and so on. That is the reading by the programming environment. This is the programming module. Now here A0 chip selection address A0 and A1 both are the indicated. A1 of the 8086, A2, A1 and A2 connected to the 8255 corresponding A0 to A1 pins. Now these two MSB bit is the LSB bit of the address lines is used for the chip selection signals. Now here is the indicated 074, whatever may be the sequence of the 0740. Select this chip selection. Port A address is the 00 is the select the port A, A0 and A1 corresponding A1 and A2. Next is the indicated as the 01, 02, 03. MS the first A1 and A2 both are the 110. That means as the 6 0746 is the select. This is CWR. 0740 select the port A. 0742 select the port B. 0744 select the port C. 0746 select the control board. First here is the select 82 control board loaded into the CWR of 8255 using out. AL is loaded by the 82. The port address of the CWR of 8255 loaded into the DX. It is the 16-bit. Using the out statement, 82 is the loaded into the CWR of 8255. CWR of 8255 given address in the problem 0746. Next, subtract dx value. Now, that is the indicated for the read the content. All keys are the opened or not. This is the programming sequence for the LEDs interfacing. And read the sequence and services to the output to the LED. Port A is act as the output and port B is act as the input sequence of the information. Next, ADC, analog to digital conversion. This is the indicated for the successive approximation register. This is the indicated input. It is the analog inputs, whatever may be your sequence. There are connected services by the 8 channels individually. You are selecting any one of the channel depending on the control board. You are select any one of the channel. That channel strength compared to the predefined successive approximation voltage. If it is equal, that corresponding bit patterns services to the output. Now these bit patterns with the help of the resistor ladder circuit generated as the voltage signal. All are is the reference voltage is the indicated for the, for example, in the 8-bit 0 to 5 variation of the analog signal. 0 is the indicated binary sequence is the 0 0 0. 5 is the variation is the indicated as the all are is the ones. 0 to 5 there are sampled by the 256 samples of the signal. 5 volts divided by the 256 we get the 1 sample. Corresponding of the binary samples we get output signal. This is the indicated ADC conversion. Now here ADC analog to digital conversion. Input is access analog information via input channel 2 with the help of the selection that are the channel 0 or channel 1 that are the selection by the ADC ABC. If it is the 0 1 0, select this second input channel. Now this input channel controlled, it is the mode 1 controlling PC0 and PC7. That is the start of the conversion, analog converted into the digital with the help of the successive approximation. After conversion is over, EOC signal is enabled. If EOC is enabled, read the content via O0 to O7 input binary pattern of the 8-bit. That 8 bits loaded to the 8086 with the help of the 8255. This is the indicated as the ADC analysis. Now similar to same circuit changes by the 0740 that are the indicated for the DAC converters. Now the next is the indicated as the DMA, direct memory access. Without CPU interaction, IO devices content services to the internal memory or hard disk, from the hard disk to the external hard disk to the external IO devices with the help of the direct memory access. Now in minimum mode, in 8086 minimum mode, there are 2 pins are the reserved, that are the pins 30 and 31. Hold and hold acknowledge is based on the access handshaking procedure services the 8086 content to the IO devices via DMA. In maximum mode, the same pins 30 and 31 requesting and granting. There are 2 DMAs are the services directly IO devices content via DMA. Now DMA, there are 2 ICs are there. One is the indicated as the 8257 and second one is the 8237. 8237 or 57, there are 4 channels are there. Address allocation of this address is the services for the 16 bits. There are 64 kilobytes of the section memory. Now this is the indicated as the DMA controller. There are 4 channels that are the DMA requesting, DMA D requesting 0 to D requesting 3. that are the D acknowledge 0 to D acknowledge. These DMA requesting or DMA acknowledgement services towards on the IO devices. IO devices. IO read and IO write, memory read or memory write, that are the indicated for the services for the reading or writing of the IO device. Hold and hold acknowledges signals towards on the 8086 communication lines. DB0 to DB7 connected to the 80 to 87. Now address lines are the indicated for the, there are 8 address lines that are the A0 to A7. Now this is the indicated for the block diagram of the DMA. That is the first initially loaded for the starting address of the word block, and how many number of bytes are services that are the indicated as the counting address. Now your bit by bit services count value is the decreases when counted to the 0, or the bulk of content is transmission is over. Next, 8237 internally current address register, the address of the current byte, current word register, how many number of words are transmitted present, that is the current word register. Command register operated, mode, the speed of our mode selection, requesting grant or requestion permission, that is indicated as the requesting register. Temporary registers. Now current address registers, one 16-bit register for each channel. There are 4 channels. Every channel is individual current address register. Hold the address of the current DMA transfer. Current word register keep the byte count, generate the terminal count after completed byte transfer from 0. Next, a command register used to program internal modules selections. Next, a mode register, each channel can be programmed, read or write, automatic, auto incremented or auto decrement address, auto initialization of the channel. Request register for software initiated or mask or status register or temporary register, memory to memory transfer. Next, a single cycle transfer, only one single transfer takes place, used for slow devices for slow communication. Bulk of transfer. Now, bulk of content is the transfer after terminated the your command. Demand transfer based on the your requesting services the information. Now cascading mode. There are more than 18237 are connected in the mode of cascading mode. The next interfacing device is the 8259, that is the a programmable interrupt controller. Each 8259 services by the 8 interrupt requests that are the IR0 to IR7. If any interrupt requesting are ready, resolve that interrupting priority base, that interrupt requesting services to the 8086 with the help of the pin number 17, that is the INT. Receiving the acknowledgement from the 8086 via pin number 26 and services the any one of the interrupt requesting. Now more than 18259 are cascading with the help of the CSA0 to CSA1 and CSA2. There are 8 8259s are the cascading. One is the act as the master, the remaining are the act as the slaves. One additional master, that are the including master, there are 7 8259s. One is act as the master and second one remaining 8 are the slaves. The total service is 64 IO devices through interrupting. Now this is the internal block diagram. Any interrupt requesting is ready. That interrupt requesting is loaded by the IRR. Based on the priority resolving, services the 8086. After completed the 8086 services, loaded for the in-service register. Now, based on the priority order of event from IR0 to IR7 order is the change based on the interrupt mask register. Now data bus buffer and read and write, these are the common for the every devices. The data bus buffer communicated towards on the 8086, read and write control logic with the help of the RD, WR bar, RA0 and CS bar of the internal 8255. Now this is the working principles. Now if any one of the interrupt requesting is there ready, based on the interrupt mask register generated as the priority order. Based on that priority order, services interrupt signal to the CPU, receiving interrupt acknowledged from the CPU and services to the 80 corresponding interrupt requesting devices. After services, that services is loaded by the ISR, that is the input service registers. This is the concept for the working flow inside the 8259. Now in 8259, there are two initialization command words are there. One is the initialization command word and second one is the operator. There are two command words. One is the initialization command words and the second one is the operational command words. The initialization command words are the ICW 0, 1, 2, 3. Operational command words are the three: OCW1, OCW2, OCW3. Based on this initialization command words, interrupts are the access. Now ICW1 and ICW is the mandatory or compulsory. ICW3 is the optional depending on the ICW1 control bit. ICW3 is not required, skip the ICW3. If it is a cascading mode, they are required to the ICW3. Again, in the special mode of transaction, they are required ICW3. Yes. Otherwise, they are not required to the ICW3. Now, compulsory ICW1 and ICW2 initialization. After that, there are need or not depending on the ICW1 SNGL bit. And next, ICW4 is not or not depending on the ICW1 bit services. This is the initialization command word flow. Now these are the indicated initialization command word format 1 and format 2, format 3. Next, there are three operational command words are there. That is the OCW1 and OCW2, OCW3. That is the corresponding any one. It is a set OCW1 set the mask register priority of order. If it is M0 is the set by the one remaining of the 0, it goes to the first priority. Or M7 is the one, it goes to the first priority. That is the priority order set. OCW3. You are select the end of command or rotate on the priority order of the specific or set priority command. This is the specified UOI command. These are the indicated automatic rotation or specific rotation, that is the OCW2. Now OCW3 is the indicated for the that is the indicated status word of the 8259 or interrupt PIC status word read. That is the read register command or polling operations. This is the indicated for the reset a specific mask or set a specific mask set, that are the control by the OCW. This is the concept for the 82. The next is the indicated for the 8279. 827, our last concept is the 8279. 8279 is the indicated as the referred to the keyboard and display interfacing. Now keyboard, it is sensed by the control signals that are the L0 to L7 keyboard, and the display is with the help of the display monitor. You are pressing any one of the key, read that information and services to the IO devices. This 8279 services 64 keys input. There are 64 keys. Display by the 16 by 8. There are 16 characters are the display, 16 characters. Each character size is indicated as 8 bit. Here is the RAM that are indicated for the 8 by 8. That is the 64 keys. Corresponding 64 values display by the 8279. This is the general block diagram for the 8279. Now the next and easiest unit compared to the third or second unit in 8086, fourth unit, that is the 386 and 486 microprocessor. Introduction, a programming model. Special purpose register, memory organization, moving to protected mode, virtual mode, memory pacing mechanism, architecture, difference between the 386 and 486. Now, previous examinations, register set of 8086 and features of difference of the 386 and 486, and registers explain the 80386 register concept. Different data types have supported 386 similar to 8086 data types. Features of 486 over to 386, address formation, a real address mode. What is meant by a paging? Discuss the paging mechanism. What is meant by a caching? These are the simple questions of the fourth unit. 80386, the 32-bit microprocessors introduced in 1985. It is logically extended by the 80286. More highly pipelined compared to the 286. 286 is the 16-bit processor, 386 is the 38-bit processor, 36-bit processor, sorry. Data is the 32-bit and address lines also 32-bit. Based on the 32 bits, you select 2 power 32, that is equal to 4 GB physical memory, and virtual memory extended up to 64 terabytes. The execution of the instruction is highly pipelined and the processor is designed to operate in the multi and multitasking. 386, the core processor is used. Same in the 8086 core processor is the 8087. Similarly, 80386 core processor is the 80387. Same core processor is the 80486 also. Now it is operated two modes. That is the paged mode and non-paged mode. The paged mode is operated up to 4 KB. It is a paged mode. Each page is the services from IO devices to the external memory to the internal memory 4 kilobytes. Now non-paged memory similar to 80286 or 8086, it is operated 64 kilobytes each segmentation. The processor can operate additional real mode and protected mode. In real mode, it is access 1 megabyte. Maximum is the it is a maximum, and minimum segment size is indicated as the 64 kilobytes. It is operated protected mode. The maximum size is the 4 GB. Now this is the very important for the examination point of view. A register organization similar to 8086. The blue shades are indicated 16-bit. The red shades extended for the 16-bit to up to 32 bits. In additionally, in 80386 added for the FS and GS, that are the segment registers used for data purpose. Now in 80386, flags, carry flag, parity flag, auxiliary carry flag, zero flag, sign flag, trap flag, interrupt flag, direction flag, overflow flag. Now NOPL is indicated, IOPL, that is indicated as input output privilege level, nested task, RF, that is the resume flag, VM virtual mode operation, AC is the indicated alignment check. The last are the indicated for the virtual interrupt flag or virtual interrupt pending or ID identification. That is the result for the 80486 bit configuration. In memory segmentation of the 386, it is maximum 32-bit address accessing. This 32-bit 2 power 32 4 GB. This 4 GB are divided into the 4 parts, that is called banks: bank 0, bank 1, bank 2, bank 3. Each bank is the 4 GB. This 4 GB access required 30 address lines. Therefore, A2 to A32 connected to the common, A0 and A1 used selected for the bank 0 or bank 1 or bank 2 or bank 3. That are the indicated for the selection of the banks. A0 and A1 0 0. It is the B0, B1, B2, B3. Now in 80386, data loaded by the little endian concept. First byte is loaded for the first bank, second byte is loaded for the second bank, third byte is loaded for the third bank, and fourth byte is loaded for the fourth bank. Only first is the lower order is the change. Order of sequence in the address A0 and A1. First is indicated as a 0. That is the BE0 selected. 0 1 BE1. Higher order sequence is the common. That is the select first address location. BE0, BE1, BE2, BE3, and so on. After completed forwards, the fifth completed 4 bytes, the fifth byte again started for the BE0, and so on. That is the filling order of the memory segmentations. Now in the 486, it is the highly integrated devices with a 1.2 million transistor. It is a 32-bit. Now internally is the designed by the 8 KB cache memory compared to the 80386. It is the improved speed of 486 processor. It is a greater extension. It is including maintain the cache compared to the 80386. Additional instructions are there that are the maintain the cache. Four-way set associative, four-way set associative, a direct mapping or indirect mapping, that are the indicated four-way set or set associative mapping. Here is indicated for the set associative mapping technique. Co-processor similar to 387. Co-processor is integrated. The chip allows its execution instruction 3 times faster than compared to the 386 of the 386 compared to the 486 co-processor is more faster compared to the 386. Now this is the comparison in between to the 386 and 486. Now cache. The main system stored the data used for the program and also instruction of the program. Cache is organized in 4-way set associated to 64 bytes or at a time is the reading containing 16 bytes or 4 double words. It is depending on the CR0 concept. Next, segmentations. The segmentation of the memory basically defined by the 3 type of descriptor tables: global descriptor, local descriptor, or interrupt descriptor table. Based on the descriptor table, your address is the extended 4 GB to the up to 64 terabytes. Now here is the loaded for the base address, offset address, and availability or controlling access of the controlling of the segment path or memory path. This is the indicated descriptor table. Now another important, for selection memory addressing, there are real mode, protected mode, virtual mode. Real mode similar to 8086. Segment address, segment register content multiplied with 16 added by the offset, we get the 20-bit address. Now in any content access within the 1 MB is called real mode. More than 1 MB, you are transfer the protected mode or virtual mode. In protected mode, first there are 32-bit or 48-bit. Now first 0 to 31, that is the select 4 GB memory location. You are exceeded 4 GB selector, that is the any one of the segment descriptor, that is the global or local descriptor table, that is the interrupt descriptor table. Based on the segment descriptor, receive the base address, added the offset, we get the memory address up to 4 GB within the memory out of 64 GB. That is the base address plus offset, we get the 32-bit linear address. In real mode, segment register content simply is multiplied, added by the offset, we get the 20-bit. That is called the physical address. Here is the 32-bit extension based on the selector and offset. Now phasing. Paging is one of the memory management technique. The memory management technique first introduced in the 486 processor for virtual memory multitasking operation system. The segment scheme may divide the physical memory into the visual variable size. Paging divided the memory at fixed size. Now each memory paging unit size is indicated for the 4 kilobytes. The paging address and paging tables defined by the paging descriptor and paging table. Now, one of the best example, convert the linear address to the physical address paging mechanism. 0 to 31 bits, that is called a linear address. This linear address divided into the 3 parts. The first 12 bits is the reserved to the offset. The next 10 bits is the reserved for the table address. The next 10 bits is the select for the directory. In 8086, there are 1024 directories are there. You are select any one of the directory. Each directory is contained for the 1024 tables. You are select any one of the table. Each table indicated 4 kilobytes, that is indicated cache size. 0 to 12, that is indicated for the offset within the paging unit. How to select? First, based on the linear address higher order 10 bits, higher order 10 bits, the directory address indicated for the CR3 control register 3 of the 80486. Added base address to the directory indicated from the base. There are variation for the 1024 directory. You are select any one of the directory. The directory table address indicated for the CR3 added for the linear higher order 10 bits. We get the one directory out of 1024. You are select any one of the directory from the base. Base is the CR3. Now you are select directory. From the directory, access table base address. Access table base address. Added for the table offset within the table base address. There are total tables 1023. That is the result 12 to 22. You are select any one of the table out of 0 to 1023. The base address of the table define the directory. The base address of the directory defined for the CR3. Now you are select any one of the table, that is called cache block or paging unit. From the page unit, you are select any one of the location with the offset. Offset is each page is contained for the 4096 that are reserved for the 12 bits. 2 power 12, that is equal to 4096. You are select corresponding address. This is the conversion from the linear address into the physical address. This is the very important for the exam point of view. Now, this is the overall conversion for the linear address into the physical address. Thank you, sir.
Okay, sir. Haq sir. Haq sir.
Share చేస్తున్నాను సార్ షేర్ స్క్రీన్ షేర్ చేస్తున్నాను.
Okay, thank you, sir. I'm ready, sir.
Thank you, sir.
Okay, sir. Thank you.
Okay, sir.
Sorry,
Haq sir.
PPT అందరూ షేర్ చేస్తాను.
Okay, sir.
Okay, thank you.
Okay, thank you, sir. అంటే సార్ స్క్రీన్ కనబడుతుందా?
స్క్రీన్ ఓకే సార్. ఒకసారి వీడియో కూడా ఆన్ చేయరా సార్?
ఓకే,
వీడియో రికార్డింగ్ లోనే ఉంది, నేను అంతా కంటిన్యూ చేస్తాను.
సరే సార్.
ఓకే,
థ్యాంక్ యూ సార్.
ఓకే స్టార్ట్. ఓకే స్టార్ట్.
ఓకే సార్. Okay, welcome to the third revision class on MPMC subject. 4 units have been dealt in the previous 2 sessions as well as today's first session. Now let me complete Unit 5 and Unit 6, and Unit 5 is related to microcontrollers and Unit 6 is also related to microcontrollers, but these are the 2 different microcontrollers. In Unit 5, we will come across 8051, and in Unit 6, we will come across PIC microcontrollers. Both are microcontrollers, but the small difference between the 8051 microcontroller as well as the PIC microcontroller is 8051 microcontroller is a CISC processor. CISC processor means a complex instruction set computer. And RISC processor means reduced instruction set computer. So both are totally different, and these are the 2 different microcontrollers we have to discuss. Now let us come to the basic difference between the microprocessor that we have seen in the previous 4 units as well, in the 4 units, and difference with respect to the microcontroller. What actually we know is microprocessor is the main part of the microcomputer system or main part of the computer, without which there is no computer. Although every each and every part of the computer is available, if microprocessor is not available, there is no computer. So with a microprocessor, along with actually the CPU that you are observing here, this is the block diagram of microprocessor. The CPU that you are observing here, it is basically a processor. Processor is called to be a CPU. Processor is called to be a CPU. So this is nothing but a processor. And in order to make a computer system, then this microprocessor need to be connected with some external devices. What these external devices are? Memory is to be connected with it externally, and input and output ports as well as devices are to be connected externally, and serial communication ports are to be connected. Timer ICs, along with these ICs, there are few more ICs that we have seen just in the previous unit, 8237, 8259. These are all the ICs which are to be connected along with the microprocessor, and together all they form the microprocessor. It means that in order to design a computer system, a processor need to be connected externally with many kinds of elements or many kinds of devices like memory, ports, all these things. But if you go to microcontroller, on the chip, this block, main block indicates a chip, and on the chip itself, you can observe a processor. Along with a processor, what are all the elements which are required to make a computer system? All these elements are available on the chip. So processor is connected external to many elements, but on the chip of microprocessor, microcontroller, you can observe all these elements on the chip. So that's why this microcontroller is also called as single chip microcomputer system. This is called as single chip microcomputer system, or onboard computer. This is called as on-chip computer. And let us come to the difference between microprocessor and microcontroller. Microprocessor, basically microprocessor, it is a general purpose CPU, and microcontroller is called as microcomputer. Why? Because all the elements are available on the chip. And this microprocessor need to be connected with memory, IO devices, timers, interrupt controllers, all these things external to the chip. But all these things are available on the chip in the microcontroller. And when you go to microprocessor, this microprocessor performs means in order to perform some operations, additional devices are to be connected, but for the microcontroller it is not required. Why? Because in order to do any kind of operation, all the things are available on the chip. And as per the requirement for the design of a computer with the microprocessor, what we can say is the systems that we design with the processor, these are all bulkier. Why? Because all the required elements, extra elements are to be connected external to the processor. So that's why the systems that we design with the processor, these are all bulkier and expensive. But the system that we want with the microcontroller, that system is a very simple one and very economic and very compact, very small in size. And there are this microprocessor do not have the instructions which can perform Boolean functions. But whereas in the microcontroller, there are specifically few instructions or a separate instruction set which can perform the Boolean functions. And the access time of microprocessors is high, and the access time for microcontrollers is less. Why? Because all the elements are available on the chip. accessing the registers or memory which is available on the chip is faster than the registers or memory available of the chip. So that's why accessing time for the microcontrollers is very less. And this microprocessor consists of very few pins, means very few pins of the microprocessor are programmable, but for the microcontroller most of the pins are programmable. Programmable means status of the pins can be varied, we can change. And there are bit handling instructions, means bit manipulation instructions. Very few instructions are there in microprocessor, but whereas in microcontroller many number of bit manipulation instructions are available. And one more point that we need to remember in microcontrollers is in microcontrollers there are registers which are called to be the bit addressable registers. Bit addressable registers means each and every bit of the register can be accessed. If you want to change a bit of a register, you can change it very well, but it is not possible with the microprocessor. In the microprocessor, all the registers are byte addressable registers. You can access the registers as a whole, not with respect to the bit, but it is possible with the microcontrollers. And because of this, the microcontrollers are basically used for the controlling of industrial machineries. And microprocessors are widely used in laptops as well as computers, but microcontrollers are used for the controlling purpose. And these microprocessors are these are the companies which are which manufactures the microprocessors, and these companies, actually these are the examples of microcontrollers. Now these are the salient features of the 8051 microcontroller. It is an 8-bit microcontroller, means the size of the ALU is 8-bit, and the number of address lines it consists of are 16. So it can access 64 kilobyte of memory. One more point that we have to remember in 8051 is following the Harvard architecture. Harvard architecture means the CPU is connected with two separate memory devices. In one of the memory, the data is stored. In another memory, the program is stored. So this is the maximum amount of memory that the microcontroller can store, and it has 8 data lines. So 8-bit data can be transferred, and on the chip, as I said, microcontroller consists of on-chip RAM and ROM, all these things. So on the chip, on-chip ROM that is available in 8051 is 4 kilobyte, and this on-chip ROM is used to store the memory. That's why this is called as code memory. And in order to store the data separately, on-chip RAM is available, and it is of size 128 bytes. Basically, on-chip RAM that is available in 8051 is 256 bytes. Lower 128 bytes it is used to store the data, and upper 128 byte is used to store. It is used for the registers. Why it is used for the registers? Let us come to the way in which the processors can interact with the IO devices. There are two methods using which the processor can interact or accesses the IO devices. What are these two methods? IO mapped IO and memory mapped IO. In IO mapped IO, IO devices are treated as separately IO devices, but whereas in memory mapped IO, the IO devices are treated as memory locations. So the microcontrollers, 8051 or PIC microcontrollers, these microcontrollers are following memory mapped IO. So that's why all the registers, these are not the registers in physical, these are basically the memory locations. So that's why each and every register which is available in 8051 microcontroller, this register consists of an address. Why? Because register is not register in physical, register is a memory location. And where these registers are available, these registers are available in upper 128 byte of on-chip RAM. Lower 128 byte of on-chip RAM is called as data memory, where the data is stored. So it consists of on-chip 4 kilobyte of ROM and on-chip 128 bytes of data memory, that is RAM. And it consists of 4 8-bit IO ports, and these are designated as P0, P1, P2 and P3, means port 0, port 1, port 2 and port 3. And it consists of two 16-bit timers, and these timers can be used as counters. So what is the difference between timer and a counter? Timer is basically used to provide the timing delays, and a counter is basically used to count the number of external activities that are happening outside of the controller. So the same element can be used both as timer as well as counter. And this 8051 on chip, it consists of a serial port, So there are two kinds of communications. One is parallel communication, next one is serial communication. When the microcontroller is communicating with another processor serially, then at that time it will make use of this on-chip serial port. And next one is, as I said, it consists of on-chip upper 128 bytes of RAM, which are the locations of the registers, and that's why this upper 128 bytes of RAM is called as special function registers. And the clock frequency, exact clock frequency of 8051 is 11.0592 megahertz. We can take this one approximately as 12 megahertz also. And this 8051 also consists of the oscillator circuit. So there is no need to connect oscillator circuit external to the 8051. It is available on the chip. But what we need to do is we need to connect a crystal external to the 8051 in order to excite this oscillator. And this 8051 supports 6 interrupt sources, 2 from the external interrupts and 3 are internal, and 1 is reset interrupt. And actually what I said is this 8051 consists of on-chip 4 kilobyte of program memory where the program can be stored. So all the time the program that we write is not of 4 kilobyte. It may be more than that of 4 kilobyte. It may be 8 kilobyte, it may be 12 kilobyte, it may be 32 kilobytes. So at that case, what we can do is we cannot store the entire program in on-chip program memory. Why? Because its size is only 4 kilobyte. So what I need to do, I need to store the remaining part of the program in the external memory. So how much of the external memory can be connected with the 8051? We can connect 64 kilobytes of external memory with 8051 microcontroller. Suppose I have written a program of size 12 kilobyte. Then what I do, I can have two kinds of options to store this program. So what are those two options? Store the 4 kilobyte of program in on-chip ROM, that is program memory, and the remaining 8 kilobyte of program in the external ROM device. So you can have this option. And another option is, instead of storing one part of the program in on-chip ROM, you can store the entire program in the off-chip ROM device. So this is one more option. And another one is you can also connect 8051 with external data memory, and its size is 64 kilobytes. And this external memory can be accessed by using read and write control signals. And this code memory is selected by external access. This is external access is a signal which indicates whether the program is entirely available in the external memory or some part is available in external and internal. And as I said, there are few registers which are bit addressable, and there are few registers which are byte addressable. And all these registers consist of on-chip RAM address. Why? Because these are all registers. These are all not the registers in physical. These are memory locations. Now let us come to the block diagram of 8051. There is an architecture of 8051, and that architecture is a little bit complex. If you cannot remember that architecture, at least you remember this block diagram. So this is an interrupt controller which is available, and this is the part of the microcontroller which acts as a CPU, and this is the on-chip oscillator circuit which is available, and this is a crystal which is connected external to the 8051 microcontroller. And these are the 4 ports, bus controller element, and this is on-chip ROM, and this is 128 bytes of data RAM, data memory. And it also consists of upper 128 bytes of RAM, which are all called to be the registers, and it consists of these 2 timers and a serial port IC or serial port element. Now let us come to the register organization of 8051. Same as that of the other microprocessors or microcontrollers. This 8051 also consists of 2 types of registers. One is called as general purpose registers, which is also called as working registers. And another set of registers is called as special function register. General purpose registers means these are the registers which can store the data, which stores the normal data values as well as the intermediate results. Special function registers means these are not the registers to store the data values. These are the registers which have some special functions, like flag register. Flag register is a special function register, and its use is not to store the data values. It is basically to indicate or to get to reflect the type of result that is being generated by the ALU. As I said, the most of the registers are bit addressable, and means individual bits can be accessed, and remaining are the byte address bit. And there are 216 there are all the registers in 8051 are all 8-bit registers except 2 registers. And what these 2 registers? Program counter as well as data pointer. These are the 2 registers which are the 16-bit, and all the remaining registers are 8-bit registers. And all the registers consist of the on-chip RAM address except one register, that is program counter. These are all the important points related to the registers. Now let us come to the general purpose registers. Accumulator. As you all know that accumulator is a general purpose register which can store the data values, and this is the register which also accumulates the result. That's why this is called as accumulator. And it also consists of one more register which is called as B register, and its operation is basically observed in multiplication and division operations. Whenever you are going to multiply two 8-bit data values, one of the data value is to be taken in accumulator, and another data value is to be taken in B register. If you multiply both the 8-bit data values, then the result is as long as 16-bit. And when the result is 16-bit, then there should be a 16-bit register to store the 16-bit result. But it is not possible with the 8-bit register. So that's why what will happen automatically inside this 8051 is the lower part of lower 8 bits of 16-bit result is stored in accumulator, and upper 8 bits of 16-bit result is stored in the B register. The same kind of thing happens during division operation also. When there is a need to divide an 8-bit value with another 8-bit value, the 8-bit dividend is to be taken in A register, and 8-bit divisor is to be taken in B register. And when you use div instruction to divide, then it provides two results. One is quotient, another one is remainder. Quotient is stored in accumulator, remainder is stored in B register. So this is the special application of the B register. It is basically a general purpose register. And apart from these two general purpose registers, there are few more general purpose registers which are designated as R0, R1, R2, like that up to R7, totally 8 registers. Okay, so there are 4 banks, and each bank consists of 8 general purpose registers. These are designated from R0 to R7. And these register banks, these are nothing but the starting 32 locations of the 128 bytes of on-chip RAM. So among these 4 register banks, only one register bank is selected by default, that is register bank 0. And the remaining 2 register banks, register bank 1, register bank 2, and register bank 3, these are to be selected by using some specific bits of the flag register. You can observe over here. So see here, this is the on-chip 128 bytes of RAM that is available in 8051 microcontroller. So up to 00 to 7F, this is lower 128 bytes of RAM, and from 80 to FF, this is upper 128 bytes of RAM. So these upper 128 bytes of RAM, these are the memory locations which are being used as registers. So that's why this part is also called as special function registers. And in order to access these, you need to make use of indirect addressing mode. Indirect addressing mode means through the register, the memory locations are to be accessed. So in the lower 128 bytes of RAM, this is further divided into 3 parts. One is general purpose register, and these are 32 locations, 00 to 1F, totally 32 locations. And these 32 locations are divided into 4 banks, bank 0, 1, 2, and 3. And each bank consists of 8 registers, R0 to R7, R0 to R7, R0 to R7. By default, only register bank 0 is being used, and the remaining banks are selected by using specific bits of flag register. And you can observe another part of this lower 128 bytes of RAM, which is also called as bit addressable RAM locations. Bit addressable RAM locations means from 20 to 2F. All the locations can be accessed bit by bit. It is possible with this. And in order to access these, there are few bit addressable instructions. And you can come across the other part of this lower 128 byte of RAM. That is, these are all the byte addressable locations, and you can make use of these byte addressable locations to store your required data values for specific operations or your required operations. Now there are special function registers which are called as stack pointer. You know very well about this. It indicates the present top of the stack, and program counter, its size is 16-bit, and it holds the address of the next instruction to be executed by the controller. and program status word. Basically, flag register in 8051 is also called as program status word, and it is basically a flag register. It indicates the result obtained from the ALU. And next one is data pointer. Data pointer. What is the use of a data pointer register? Data pointer is a 16-bit register which is basically used whenever the 8051 is accessing the external program memory or the external data memory. In order to access external program memory and external data memory, this data pointer is being used, and this data pointer is not used to store the data. It is basically used to store the address of the external ROM or RAM which you are going to access. And along with these registers, it also consists of the registers specific to the special elements. What these special elements are? This 8051 consists of timers, and in order to handle these timers, these are the registers. These two form 16-bit register for timer 0. These two form 16-bit register for timer 1, and these can be used as 8-bit registers also. TH0, TL0, actually it forms a 16-bit timer 0 register, and these two forms timer 1 16-bit register, and these can be split into 8-bit registers also. And in order to hold the data that is being transferred through the port, there are few port buffers which are designated as P0, P1, P2 and P3. These are basically used to store the data values that is being accessed through the ports, and these ports are parallel ports, not the serial ports. And next, there are some control registers in order to control serial communication, timers, all these things. And these are TCON, TMOD, PCON, CCON, SCON, IE and IP. TCON means timer control, TMOD means timer mode control. These are the two registers used to handle the timers. And power control register and serial control register, along with one more register which is called as SBUF, serial buffer register. These are the three registers used to handle the serial communication. And in order to handle the interrupts, there are two specific registers which are called as interrupt enable register and interrupt priority register. Now let us come to the stack pointer. It is an 8-bit byte addressable register. It's not a bit addressable. And you can make use of two instructions, push and pop, in order to handle the data from stack, in order to access the data from the stack or data at the stack locations. For each push instruction, the stack pointer is incremented by 1. And for each pop instruction, the stack pointer is decremented by 1. And whenever you reset 8051 microcontroller, then this stack pointer is initialized with 07. Means from 08, these are all the stack locations. So next one is program counter. Program counter is a 16-bit byte addressable register. It is not a bit addressable. And in order to access the on-chip program memory as well as off-chip program memory, whose size is of 4 kilobytes and 64 kilobytes respectively, in order to access the data, in order to access the code bytes from the program memory, this program counter is used. It is basically used to show the address of the next instruction to be executed, same as that of processor. And this is the register, only register available in 8086 which doesn't have any RAM address, and all the registers consist of on-chip RAM address. This register doesn't have the address. And data pointer register, it is a 16-bit register as I said, and it can also be used as two 8-bit registers. One is DPL, another one is DPH. And what for this data pointer is used? Data pointer is used to access the external memory. What that external memory? External data memory, external code memory. And what is the size of external data and code memory? External code memory size is 64 kilobytes and external data memory size is also of 4 kilobytes. In order to access the external data and code memory, these are the two instructions which are used, MOVX and MOVC. And the address of the external data memory or the code memory is basically being taken in data pointer register. Direct memory addressing is not possible whenever you are accessing external data or code memory. It is possible with indirect addressing mode, and to hold the address, data pointer is used. And there is a specific instruction to increment the content of the data pointer, but there is no instruction using which the data pointer is being decremented. Now this is the format of the program status word. What I said is it is a flag register and it is an 8-bit register. You can observe the flags here. CY means carry flag, AC means auxiliary carry, OV means overflow flag, P means parity flag. You can observe RS0 and RS1. This is register select. These are the two bits using which the register banks can be selected. So how many register banks are there? Totally 4 register banks are there, and these 4 register banks can be selected by changing the values of these 2 flags. And this is the user defined flag. User defined flag means for your own application you can make use of this bit. And these are all the special function registers, and each and every register you can observe the addresses, except program counter. There is no program counter here, and the remaining registers are available here. These are all consists of on-chip RAM address, and among these registers there are few bit addressable registers, there are few byte addressable registers. You can observe what register is bit addressable and what register is byte addressable. See here. So these are not shown here, nothing. So these are all the byte addressable. Whichever is the bit addressable, those are shown here. Now let us come to the memory organization in 8051. As I said, this 8051 consists of on-chip 256 bytes of RAM, and this on-chip 256 bytes of RAM is divided into lower 128 byte and upper 128 byte. Now let us come to the diagram. And lower 128 bytes is used to store the data, and if it is not possible to store your data in on-chip RAM, you can make use of external RAM. And how much of the external to connect external RAM means we can connect 64 kilobytes of external RAM. And what is the address range of data memory? 00 to 7F. And what is the range of external data memory? It is of 000 to FFH. And this is the address range of special function registers. And this is the amount of the external program memory that we can connect with 8051. So I discussed this one in the previous slides. This is 256 bytes of on-chip RAM. It is divided into upper 128, lower 128 byte. Lower 128 is further divided into 3 parts. Now see here, from 00 to 1F, these are all the registers of register 3 register banks. From 20 to 27, these are all the bit addressable locations, and each bit of the register consists of unique address. Using this address, you can change this bit. For that, I can make use of instruction set B 01. If I write set B 01, then this bit will be set. If I write clear 09, then this 09 location, this 09 bit will be 0. Now the remaining memory locations from 28 to F7, 30 to 7F, 30 to 7F. This is the third part of the on-chip lower 128 bytes of RAM, and these are all the byte addressable locations. So for your own applications, you can make use of these locations. Next, these are all the registers which you can observe in upper 128 bytes of RAM. So that's why this upper 128 bytes of RAM is called as special function registers. Now see here, let us see some examples to access the on-chip RAM. If I write move 40H comma R0, what does it mean? A data from R0 register is being transferred to the on-chip RAM location whose address is 40. Now move C is carry flag, comma 24H. This 24H is the bit addressable location. It's a address of the bit. So a bit from 24H bit addressable location is being carried over to carry flag. Next one is set B 24H, means this bit location 24H is being set by set B instruction. Clear 26, bit addressable location of address 26 is being cleared, means this bit location will get 0 after the execution of this instruction. Now see here how much of the on-chip and off-chip ROM means program memory is available. This is a total 4 kilobyte of on-chip ROM used to store the program, and if it is not sufficient, you can make use of external memory also. And how much of the external memory we can use? 64 kilobytes. So its address range is 00 to FFH. So there are 2 options, as I said. If you want to store the program whose size is more than that of kilobytes, there are 2 options. You can store 4 kilobyte of the program and the remaining part of the program in external memory. Or another option is the entire program you can store in external program memory. Now this is the internal architecture of 8051 microcontroller. Whatever we have discussed about registers, ports, all these things are available over here. If you cannot remember this internal architecture, at least you can remember the block diagram of 8051. Now this is the pin diagram of 8051. So according to the ports and the special applications, we can remember this pin diagram, and it is not means what we can say, it is not necessary to remember all the pins. If you cannot remember all these pins, just leave it. At least you remember these designations. So as I said in the previous slides, this 8051 consists of 4 ports: port 0, port 1, port 2, and port 3. So this is port 0, this is port 1, this is port 2, and this is port 3. Among these 4 ports, port 0 and port 2, these are the 2 ports which are used to handle the address of external memory or address of devices, IO devices. And this port 0 is also used to handle the data values, means data and address signals are time multiplexed with each other. And what is port 1? Port 1 is a normal port. There is no alternate application of port 1. There is no additional application of port 1. Port 1 is basically used as IO port only. But when you go to port 3, this port 3 along with port operation, it also performs some additional operations, special functions, special operations. What these special operations? P3.6 can be used to generate write bar signal, and this can be used to generate read bar signal. And these are the 2 signals, 2 pins which are used to handle the on-chip timers which are available in 8051. And these are the 2 pins which are available to handle the external interrupts. There are 2 external interrupt pins, INT0 and INT1. And similarly, this 8051 port 3 pins are also used to handle the serial communication. In order to receive the serial data, this pin is being used, and in order to transmit the serial data, this P3.1 pin is used. These are the special applications of port 3. Along with these pins, there are few pins which are called to be program store enable, address latch enable. It is same as set of the ALE signal in 8086, and this is external access, and this is reset, and these are the oscillator pins. These are the oscillator pins. Internally, on-chip oscillator is available. In order to run that on-chip oscillator, these 2 pins are to be connected with the crystal along with these capacitors. And these are the power supply pins. Now let us come to this is the actual pin diagram. Now let us come to the the operation of each and every pin of 8051. And as I said just now, port 0 and port 2 can be used to handle the address as well as data, and port 1 is normal port to handle IO data values, and port 3, apart from its IO operations, it can also be used to handle some external applications like serial communication, timer handling, all these things. And now see here, by default, all the ports acts as input ports. All the ports acts as input ports. If you want to configure ports as output port, what you need to do is you need to send zeros to that port buffer. If I send 00 to port 2, then this port 2 acts as output port. If I send 11 to port 1, then this port 1 acts as input port. So by default, ports are acting as input ports. If you want to change the configuration of ports, you can very well do this by sending ones and zeros. And power supply pins, the power supply to 8051 is 5 volts, and this is ground pin, and XTAL1 and XTAL2, these are the 2 pins in between which the crystal of value 12 megahertz is to be connected along with some capacitors in order to trigger the on-chip oscillator circuit available. See here, this is the actual connection that you need to give to the XTAL1 and XTAL2 pins in order to run the on-chip oscillator circuit. So this is 8051. These are the XTAL1 pin and XTAL2 pins. These are the 2 pins in between which an oscillator of value 12 megahertz approximately is connected along with these 2 capacitors. So when I connect, when I do this kind of setup in between XTAL1 and XTAL2, then 8051 starts running. Depends upon your input. And one more way using which you can run the internal oscillator is, if you don't have this oscillator available to 8051, it's not a problem. You can make use of XTAL2 pin. You can take external oscillator circuit, connect the output of the external oscillator circuit to XTAL2 pin in this way. I don't have a crystal, so what I do, I take external oscillator circuit, connect the output of external oscillator as an input to XTAL2. Then what will happen? Your 8051 will start running. And one more point that you need to remember is actually whatever the operations that are happening in 8051, these are not happening with respect to the clock pulses. These are happening with respect to the machine cycles. And what is the length of machine cycle? The length of machine cycle is 12 clock pulses. So the clock input of this 8051 is approximately 12 megahertz, exactly 11.0592 megahertz. So means the number of it indicates the number of clock pulses per second. If I take the reciprocal of this value, then I can say how many means the duration of the each clock pulse. So the machine cycle is basically machine cycle is nothing but if you divide the clock frequency with 12, it is nothing but the clock frequency to 8051 in terms of machine cycles. And what is the length of machine cycle? The duration of machine cycle is 1.085 microseconds. So in 8051, each and every activity happens at this time, 1.085 microseconds. At each 1.085 microseconds, each and every operation happens in 8051 microcontroller. So this point we need to remember. All the operations that are happening inside the 8051 microcontroller is with respect to machine cycles, and the length of machine cycle is 12 clock pulses, and the duration of each machine cycle is 1.085 microseconds. So this is about RST. So RST is an input by applying an active high pulse of duration to machine cycles, then 8051 will be reset. So what will happen upon resetting 8051? When you reset the 8051 microcontroller, all the registers are cleared except stack pointer. This stack pointer is initialized with 07, as I said in the previous class, previous slides. And all the ports by default acts as input ports. So this is what the operation that is happening. RAM is cleared, ports acts as input ports, all the registers are cleared except stack pointer, which will be stored with 07. So this is what the setup that you need to connect whenever you are going to use 8051 microcontroller. Now see here, this is the setup in order to apply the reset. When you press this key, then this 8051 will be reset, and this is actually the setup for setup to make the on-chip oscillator to run. So this is the setup that you need to connect external to 8051 in order to reset this. If you press this, the circuit will be reset. Now one more point that you need to remember is this is the setup that you need to take for 8051 for all the kinds of interfaces, without which there is no output. Now see here, what is the main use of external access pin of 8051? The main use of external access pin of 8051 is, as I said, you can store entire program in the external memory, or some part in internal and another part in external. If some part is stored in internal, another part is stored in external, then external access is 0. If external access is 1, if external access is 0, it means that the entire program is available in the external program memory. Just to indicate 8051 whether the entire program is available in the external program memory or some part in internal and another part in external, that is indicated by external access. And one more thing is program store enable. So this program store enable is such an output signal from 8051 which indicates that the 8051 is accessing the program from the external memory. If the 8051 is accessing the program from external memory, then PSEN pin will become logic 0. If it is 1, it means that 8051 is accessing on-chip program memory. Now this is ALE, it is same as setup ALE of 8086. Now let us come to the programming part of 8051. I don't discuss the programs of 8051. I will discuss only addressing modes as well as some instructions, and directly go to the interfacing part. Now there are 5 different kinds of addressing modes. You know very well about immediate addressing mode. So direct data value is being transferred to the register or the memory location. And register addressing mode means data is being handled or carried by the registers. Direct addressing mode means data is being carried by the memory locations, which is being indicated with its own address. And register indirect addressing mode means the data is available in the memory locations which are being accessed by using registers. And base register plus index register addressing mode, it is also an indirect addressing mode wherein the content of two registers are being added to locate the location. Now immediate addressing mode, the data value is basically used as one of the operand. Now see here, you can observe this, add a comma 30. If a value is being taken with hash symbol, it is a data value. It is being added with accumulator and the result is stored in accumulator. Next one is move dptr comma hash this. This is a data value which is being carried to dptr. And register addressing mode. In this register addressing mode, what we can say is the data is being carried by the registers. You can observe the examples here. Move a comma r7. The data in r7 register is being moved to the accumulator. Move r7 comma a. The data of accumulator is being carried over to r7. Move c comma 24. The data bit of 24 location is being carried over to the carry flag. With respect to the carry flag, this is register addressing mode. With respect to this address, this is direct addressing mode. Now let us come to the direct addressing mode. There is no hash symbol here. If there is no hash symbol, this is not a data value. This is the address of on-chip RAM. This is the address of on-chip RAM. The data from the on-chip RAM location is being carried over to the accumulator. So this is indicating the direct addressing mode wherein the data is available in the memory whose address is taken directly. Now this also come under direct addressing mode. Why? Because the registers in 8051 microcontroller consists of the RAM address. So if you take the label, they are nothing but the RAM locations. Means you are just transferring the data in between two RAM locations. But they are designated as registers like A and P3. Now see here, register indirect addressing mode. In this register indirect addressing mode, the on-chip RAM locations are accessed by using the register indirect addressing mode. And in this register indirect addressing mode, the RAM locations which are being accessed, these RAM location addresses are being carried by only two registers, R0 and R1. In the register indirect addressing mode, you can make use of only these two registers. If you are going to access the external RAM and ROM, external data memory and external program memory, then you have to make use of DPTR as I discussed in the previous slides. You can make use of examples here. See here, move @R0 comma a. What is happening here? The content of accumulator is being transferred over to the location which is indicated by the register R0. What is there in R0? 25H. Means the content of accumulator, which is 4A, is being transferred to the location 25H, and this 25H location is pointed by R0 register. Similarly, a content of accumulator is being transferred over to the location which is pointed by DPTR register. Indirect addressing mode is being indicated with @ symbol. Data value is indicated with hash symbol. Base register and index register indirect addressing mode. In this indirect addressing mode, basically this indirect addressing mode is used to access the external RAM as well as external ROM devices. Means external program memory as well as external data memory. So in order to do so, we can make use of move C instruction and move X instruction also. And basically it is used for code access, external code memory access. And in order to access the data values, in order to access the code from the external code memory, we need to add a DPTR or PC with accumulator. Then whatever the address we get, that is the address of the external code memory, and then we can access that location. Now these are the set of instructions which are available in 8051. So you know very well about data transfer instructions, means move, exchange, all these things, arithmetic, logical, bit manipulation instructions, program and machine control instructions. These are all the branching instructions. See here. So these are the symbols that we are basically used for representation of the addressing modes. RN is used to represent the register, and direct is used to indicate the direct address. @RI is used to indicate the indirect addressing mode. This indicates the direct means immediate addressing mode, wherein the data value is 8-bit. This indicates immediate addressing mode with data value of 16-bit size. and this bit indicates the address of bit addressable location. A is nothing but accumulator. You can see all these instructions, move instructions. What is happening here? Content of a register is being transferred to another register A. What is happening here? The data value is being transferred to register Rn. What is happening here? The content of location which is pointed by Ri is being transferred to the location whose address is given at this position. Now these are all the push instructions, exchange instructions, move the data value to the external locations, all these things. These are all arithmetic instructions. You know very well about all these things. These are all same as that of your 8086, but small difference is there. These are all logical instructions: logical AND, logical OR, logical XOR, clear, complement, rotate instructions, and swap instructions. There is no shift instruction in 8051. These are all rotate instructions. And bit manipulation instructions. These are the instructions which are used to manipulate the bits, do some operations over the bits. Clear the carry flag, clear the bit location, set the carry flag, set the bit location, complement the carry flag, complement the bit location, perform AND operation over 2 bits. What those 2 bits are? Carry bit and the bit addressable location. Perform OR operation, move 1 bit from another bit, move a bit from one location to another location. So these are all possible with bit manipulation instructions. Now program and machine control instructions, these are nothing but branching instructions, and there are 3 kinds of branching instructions. What these 3 kinds are? One is short, absolute, and long. So for short branch instructions, the duration, or what we can say is, for short branch instructions, the length to which the processor jumps is upper 127 locations and backward 128 locations. And when it is absolute branching instruction, then the 8051 jumps within 2 kilobytes of program, 2 kilobytes of program memory right from the instruction. Whereas in long branch instruction, the length, the 8051 microcontroller jumps is within 64 kilobytes of program memory. So this is the means what we can say, this is the length to which the 8051 jumps in order to execute the next instruction. So these are all the branching instructions. Call instruction to call a subroutine, return from subroutine, return from interrupt service routines, absolute jump, long jump, short jump, normal jump, jump if 0 flag is set, jump if 0 flag is not set, jump if carry flag is set, jump if bit is set. So these are the 2 important instructions. CJNE, compare and jump if not equal. What not equal? If A and the value in the location is both the values are not equal, then you take a jump where which is indicated by the relative address. So there are 4 kinds. Similarly, DJNZ. DJNZ means decrement and jump. Decrement and jump if it is not 0. What is to be decremented? The register value Rn. Decrement the content of register Rn and then take a jump if it is not equal to 0. Where to jump? It is indicated by the relative address. Similarly, jump the content of the location. If it is not 0, decrement the content of the location. Address is given by direct, and if it is not 0, take a jump to the relative address. Now see here, in the interfacing part, actually what you need to do is you just take 8051 and then take this connection. This is mostly required, without which there is no interfacing, and it is your wish. You can take this setup or not for the reset purpose, but you must and should have to take this. So what I am going to interface here, LED interfacing. I'm just connecting 2 LEDs over to 8051. One LED is to port 1.0, means last port pin of port 1, and second port pin of port 1. These 2 LEDs are connected to port 1, and what I'm doing here is I'm just blinking the LEDs, make it on and then off and then on and then off. In order to do so, what I need to do is I need to send zeros to port 1 and then provide a delay, and then send ones to port 1 and then provide a delay, and then send zeros to port 1. Like that, if I send zeros and ones continuously with some delay, these LEDs will be glowing on and off. Next one is 7-segment display. This is a 7-segment display which is configured in common cathode configuration. Now this 7-segment display is connected to port 1, and this setup is not mandatory, it is optional, but this setup is mandatory as I said. And port 1 is connected to 7-segment display. What you need to do is you need to write a program in such a way that send the specific values to port 1 so that the required character is displayed over here. See here, as it is in common cathode configuration, the values that are to be sent over to the 7-segment display are these values. If you send these values to the 7-segment display, then you will observe the numbers 0, 1, 2 like that up to 9. So this is the interfacing. These are very simple designs. Take 8051, connect this, connect 7-segment display, and then write a program to send all these values to port 1. Then you will get 0, 1, 2, 3. See here what I'm doing here. I'm taking first value, send it over to port 1, provide a delay, then send this value to port 1, then this will be displayed like that. All these things will be displayed. Okay, and this is a DSC interfacing of digital to analog converter with 8051 microcontroller. It is same as set of your 8086. We can observe this kind of setup in 8086 also. And what for this DSC? DSC can be used to produce different kinds of waveforms. Now this is the program to generate step ramp, and this is to generate the square waveform. Similarly, we can generate triangular waveforms, we can generate sine waveforms just by sending the specific values to the port. Now let us come to the few additional features of 8051. This 8051 consists of timers. As I said, the timer can be used as a timer, and timer can also be used as counters. So what is a timer? Timer is basically a circuit used to provide some time delays, and counter is nothing but a circuit which is used to count the number of external activities that are happening to external to the 8051. Now if the timer is acting as a timer, it will take the input from T0 pin of the processor. This T0 pin is provided at port 3. So for timer 0, T0 pin; for timer 1, T1 pin. So if it is acting as a timer, it will take input from T0. If it is acting as a counter, it will take the input from the clock. And in order to handle timers, there are two specific timer registers, T0 and T1. And these T0 and T1 can be further divided into two 8-bit registers, TH1, TL1, TH0 and TL0. Now there are 4 modes of operations of timer: mode 0, mode 1, mode 2 and mode 3. So in mode 0, the timer can be used as a 13-bit timer, and in mode 1 the timer can be used as a 16-bit timer. In mode 2 it is used as a auto reload mode. Auto reload mode means actually this is a mode wherein the timer acts as an 8-bit timer, and automatically whenever the overflow occurs, then the value will be loaded, and then the timer again starts running. Means continuously the timer is running in the auto reload mode until you stop it. Mode 3 is called as split timer mode. Why? Because there is a significance of timer 0 only in this mode, and there is no significance of timer 1. And this timer 0 is used as two 8-bit ports separately, two 8-bit timers separately, that is TH0 and TL0. These are used as two 8-bit timers. In order to handle the timers, there are two specific registers which are given, which is TMOD register, TCON register. In order to change the mode of operation of timers, TMOD register is used, and in order to control the timers, whether to start the timer or stop the timer, that is being controlled by TCON register. Similarly, serial communication, that is one of the best feature of 8051, wherein the 8051 can communicate with other processors serially. And this 8051 supports full duplex communication. So it can receive or transmit the data serially with the other processor or the other external device. In order to transmit or receive the serial data, it consists of 2 pins, P3.1 and P3.0, to transmit and receive the data. And in order to handle, registers are given, serial control register and power control register. Now see here, this is what the framing of the data whenever the 8051 is going to perform the serial communication. This is an 8-bit data. So this 8-bit data is appended with start and stop bits, and sometimes this data may be appended with another 9th bit, which is called as the parity bit, and this is to check whether the error happened or not. Now, one more point is the number of interrupts that are being handled by 8051. The 8051 handles 5 different interrupts, 2 external interrupts generated by the external devices, and timer interrupts. What is a timer interrupt? When the timer runs or counter runs, if overflow occurs, then interrupt is generated as an indication, as an acknowledgement. That interrupt is called as timer interrupt. Similarly, whenever the data is being sent or data is being received, then also there is an interrupt which is generated. That interrupt is called as serial port interrupt, and it is a combination of 2 interrupts. One is receive interrupt, another one is transmit interrupt. When transmission happens or reception happens, at both the conditions the interrupt is generated. That interrupt is called as serial port interrupt, and this is the priority of the interrupts. This one has the highest priority, this one has the lowest priority. Highest priority, next highest priority, next highest priority, next highest priority goes to this, and this serial port consists of lower priority, lowest priority. Now this is all about the 8051 microcontroller. I think material has been uploaded in Binder whenever the lockdown happened, so you can go through the material. This PPT is also available in the material which has been shared after the lockdown period. Now let us come to the unit 6, which is related to PIC controller. I don't discuss much about this, just a few slides are available. Now what this PIC is nothing but peripheral interface controller, and it is being designed by General Instruments. 8051 is invented by Intel, but this PIC is invented by General Instruments. Later it has been handed over to Microchip. And what is specialty in this microcontroller? The specialty is it is a RISC computer, reduced instruction set computer, whereas 8051 is CISC. So what is the difference between RISC and CISC? In RISC, you can have few instructions and the size of each instruction is same. So within same time period, all the instructions are executed. But the problem with the RISC is when you are going to write a code or program, it will be a bit complex. Why? Because number of activities are included in a single instruction. So when you are going to write a program, it will become a bit complex. That is what the problem. And the remaining all the features are same as that of the 8051. So it is a low cost microcontroller, and it follows the Harvard architecture as it is in 8051. It consists of accumulator, reset, interrupt vectors, and all the things. Now see here. There are 2 kinds of microcontrollers, PIC microcontrollers you can observe, which are designated with letter F and letter C. If you can observe the PIC microcontroller with letter F, it consists of flash program memory, and if this PIC microcontroller is designated with character C, then it doesn't have flash memory. It consists of EEPROM for program storage, and that means PROM memory, PROM program memory, wherein the erase operation happens with ultraviolet light. There are some PIC microcontrollers wherein EEPROM program memories are also available. Now let us see the different kinds of PIC microcontrollers which are available. These are all the microcontrollers, but the most important microcontroller is this one, 16F877. So what are all the features? It consists of 8 kilo bytes of program memory, but here the byte is not actual byte. This PIC microcontroller consists of 8192 program memory locations. Each location size is 14 bits, and the size of data memory is 368 bits. And it also consists of EEPROM for data storage, whose size is 256 bytes. And its clock frequency is 20 megahertz, and it consists of 33 IO ports, a lot more than that of 8051. And it consists of 8 different A to D converters available on the chip. Now, why this PIC 16F877 is popular? Why? Because it is very, very cheap, and it is very simple to assemble the external devices with this PIC microcontroller. So in order to design any system, what you need to do, you need to have simple elements, like you need to have a power supply of 5 volts, you need to connect a crystal of 20 megahertz, along with the capacitors, then you can write program and then run your application. And what are all the advantages of PIC 16F877? The advantage is 10,000 times you can erase the program and reprogram the program memory. 10,000 times you can do erase and program it for your application. Means you can run 10,000 applications on this PIC microcontroller. This is what the advantage of PIC 16F877 is. But the disadvantage is on-chip oscillator is not available. You need to connect the on-chip oscillator externally. You need to connect the oscillator externally. Now these are all the features. Operating frequency 20 megahertz. It consists of 8K flash memory, and each memory location can store 14 bits. And data memory is 368 bytes. It also consists of one more data memory, which is a ROM type, and it can be erasable and programmable, and its size is 256 bytes. And it consists of totally 33 IO ports. 3 timers it has, and it consists of one more module which generates the PWM signals to handle the external machinery, motors, and it consists of serial communication ports, parallel communication ports. Basically, these IO ports are also called as parallel communication, but separate ports are also available here. And it consists of 8 channels of A to D converters, and it consists of 35 instructions, and it is a 40-pin IC. This is the pin configuration. Now this is the basic architecture of PIC 16F877. So it consists of ALU, W register, timing and control unit, IO ports, and on-chip RAM of size 356 bytes. And it also consists of on-chip another data memory of size 256 bytes, and it consists of flash memory, each location of size 14 bits. Now this is all about program memory, data memory, and EEPROM. Program to store the program, program memory to store the program. It is a flash memory, and it consists of normal data memory of size 356 bytes. And there is one more memory. Means always you cannot means what is the problem with this data memory? The problem with this data memory is when the power is off, the data that you stored is erased. If you want to store the data permanently, then you need to make use of another data memory, which is EEPROM memory, which is also available on the chip. So data that you want to need to place there permanently, you can make use of this data memory. And if you are using temporarily for your application, then you can make use of this data memory. So this is all about the basic features of the PIC. So whatever the materials that you need related to all the 6 units, as well as these PPTs are uploaded in your Binder account. You can go through your Binder account and then download these PPTs as well as materials. So thank you for attending this class.